In this video, we're going to take a look at some of the bit instructions that are commonly used in the Studio 5000, RS Logix 5000, and other Allen Bradley PLCs such as RS Logix 500 with the SLICs and the MicroLogix. So I've created a new project, and I've already got the project created. The only other thing I'm currently going to do is, before I can do anything in my ladder, I need to add an I/O module to this particular project. I'm using a 1769 L30ER controller or processor. You can see that down here. And I'm going to click on the bus and right click and add new module. I'm going to turn everybody off. I'm interested only in digital, so I'll turn on the digital. And the module I'm using is a 6-point DC in, 4-point AC/DC relay out. So it's that module right there. I've highlighted it. I'm going to click create. At this time, I'll give it a name for the module. I'll just call it DC in out. It's going to be in slot 1. And I know the revision is a 3.1, so I'm going to change this from 2.1 to revision 3.1. And we'll talk about that a little more in other videos of what's the keying got to do with setting up a module and things of that nature. So I'll leave everything as is. I'll click OK, and you should see it now over here under the left under my processor. Close that window. Now, we talked in a previous video about creating a basic input output in a different video, but in this one we're going to add a few items into it. So I'm going to start out with an examine on, drag it down into my new rung. Examine on is the terminology that Allen Bradley's been using for quite a few years now. And what you'll find is it's also called an XIC. So XIC stands for examine if closed, and also in the Studio 5000 they call it an examine on. So we need to assign this an address. I'm going to double click the question mark. I'm going to go find my inputs that are in here now because I added a module. Local 1I, that's local in the compact rack. 1 is the slot, and I are the inputs. So I'll click the plus to the left. We'll go down and look for data bits. I'll click the drop down, and I'm just going to select bit 0. This particular module has 8 inputs on it. Okay, so I've assigned that to that push button, which is on my small trainer here. I'm going to click back so I'm on this rung. You'll notice everything up here is grayed out until I click back on the rung number. Now I'm just going to grab an output energize, drop it here, and go select an output. So local 1. And this is a kind of a unique time where both inputs and outputs are in the same slot. And that's because this module is an input-output module. So you're going to have local 1I for your inputs, local 1O for your outputs. We'll click the drop down, data, and we'll pick output 0. Okay. Now, in a previous video, I had this same rung in my program. But what we're going to do in this particular video is make a standard start-stop circuit like you'd have in a hardwired circuit. So I'm going to come back up here. I'm going to grab and examine off and put it down here. And one of the things I can do, I can double click the question mark and go get the next address I want. Or I can drag this one over to the left and just change the last number to a different bit. That's what I'm going to do. Now, I'm going to make this my stop button, this my start button, and this the output that's going to be going to the motor starter. But these are going to be momentary buttons. So what I need to do is I have to have some way of holding this rung true when I release the start button. So we're going to go up and get a branch, drag it around our push button that's going to be our start button, and then we will drag another examine on into our new branch and assign it the same address as our output. So we're just going to click on the output tag, drag it right into branch, and drop it right there. Now, we don't have any descriptions of any kind. All we have are tag addresses. So let's right click on this, go down to Edit Main Operand Description, and let's call this our Stop Push Button, or PB. You'll see that shows up in the background above it. I'll go do the same thing for my Start, down to Edit Main Operand, Start PB, and click the green check mark. Now on our output, this is going to be to our motor starter. So we'll edit the main operand. We'll call this motor starter 1. Okay, click check. And it puts it on both tags because they're the identical tag address. Now, if we don't like this background being white like it is above our current tags, we'll go up here to Tools, go to Options, and if I come down here to the ladder editor for the font colors, you can see I have all these different things in here I can select. I'm going to select descriptions. Currently background is white, foreground is black. I'm going to change this to a yellow. Click apply, OK, and you'll notice now my background's yellow, and I'm going to click the plus to make it a little larger. Now this will be a little easier to see and separate what's a description and what is an actual tag address in the controller. Now, we're going to download this and see if we can test this. But the first thing I notice is, since this is a new project, I currently do not have a path. And I also know that I have not configured a driver yet in RS Links. So I'm going to come down here, hit my Start button, and go start up RS Links Classic. That takes a few seconds to start up. I do not have a driver running yet, so I'm going to go up to Communications, Configure Drivers, click the drop down, and I have an Ethernet cable plugged in from my computer over to my controller, so I'm going to select EthernetIP driver, Add New. I'll leave it as the default name, click OK, and I'm going to select the IP address of my network adapter in my computer, and that's this one right here. Notice the IP address, 192.168.1.18. Click OK. Now it shows my driver is in and running. I'll close that, and I'll see it's here running in RS Links. I'm going to click the plus in front of the driver name, and if everything goes well, you should see my IP address, 192.168.1.10, and there's my processor. Now, why do I see this one under here, a micro 820? Well, I've got this on a little network switch, and I also have my micro 820 plugged into that switch. So both of these, since they're on the same network, which is 192.168.1, with a unique different IP address as the last number, they're both showing up. So I'll just click the minus to get it out of the way. We're going to go up here to the path again, click the little Who Active icon to the right of that. You see a similar window we just saw when Links was open. We'll click the plus to expand it. We'll click the IP address of our controller. You can see over here now we have several options. We're going to do a download, so we'll click download, and we'll see what's going to happen when we do that. Comes up and says, do you want to download this project to the controller? And would you like to download the documentation? What that means, if we leave that checked, these yellow descriptions are going to get downloaded to our controller. That is a new feature in Studio 5000 that we did not have in the RS Logix 5000 software. Newer controllers that we use in Studio 5000 have more internal memory, and they allow us to store more information that we could in the previous Studio software or the RS Logix 5000 software. Put it back into run mode. You can see we're running. Our stop button is true, so let's push it once just to see if it goes false when we push it. It does. Let's push the start button. That enables input 0. That turned on our output. When we let go of the output, our branch that's wrapped around our start button maintains the rung being true. And if we look over on the trainer, output 0 is illuminated. And in the real world, that would be wired to our motor starter coil, and our motor would in fact start. Now we could do a lot to enhance this to make sure that when the starter was told to run, did the actual starter pull in, but we'll leave that for another day and another time. So now we've got our start-stop circuit in here. Everything seems to be working, so we'll call that good for this one, and then we'll come back in the next video and take a look at the latch and the unlatch and to see what may be different if we utilize those.